Assalamu alaikum dear students. In previous lecture we discussed the composition of two one functions implies that their composition is also one, and composition of two onto functions is also onto, but the converse is not true in general. Now you know that if we have the identity function from set A to A, that is a function which maps the same element with itself, and simply we denote this if we have a the set A to be the given set, then identity function from A to A is simply denoted by IA. Means IA is that function which maps x of A with x. Now let's consider two sets. Set A equals to 1 to 3, set B equals to A, B, C. F is function from 1 to 3 to A, B, C, defined by f of 1 is A, f of 2 is C, and f of 3 is B. G is function from A, B, C to 1 to 3, defined by g of A is 1, g of B is 3, g of C is 2. Now here we can define the graph, that is g of f. So it is a function from 1 to 3 to 1 to 3, 1 to 3 to 1 to 3, defined by g of f of 1 is g of f of 1. Now f of 1 is here. Now f of 1 is here A, so it is g of A. G of A is here 1, so it is 1, which implies that 1 is mapped with this 1. Similarly, g of f of 2, it is g of f of 2. Now g of f of 2 is g of C, because f of 2 is C. Now g of C is here 2, g of C is here 2, so it is simply 2. Similarly, g of f of 3 is 3. So this means that g of f of x is simply x, because for 1 it is 1, for 1 it is 1, for 2 2 is mapped with 2, and 3 is mapped with 3, which implies that g of f of x is simply x for all x belongs to 1 to 3, because this 1 to 3 is the domain for this Goff function. So this means that the composition of these two functions f and g, it is identity function. Actually identity function because means that function which maps each element to itself. So here x is related with x for all x belongs to 1 to 3. So we can simply, if we denote this here, this set is denoted by A, so this means that this g of f is IA, means identity function. Similarly, if we consider the fog, because we can define here the fog by the same this way. So fog is I of B, because for fog, that is FOG, the domain is here, the domain is set ABC, which is actually B, and its codomain is also ABC, that is B. But this fog is this this identity function, which implies that actually it is simply the identity function from set B to B, that is IB. So from this we can conclude that if we have two functions which are one onto, that is which are bijective functions, that is f from A to B is a bijective, then if there exists a function g from B to A such that g of f of equals to IA, and f of g, that is fog, equals to IB, then this g is called the inverse of f, and this is denoted by f raised to power minus 1, that is f inverse of f inverse equals to simply g, that is a function f from A to B which is bijective function. If there exists a function g from B to A, that is from codomain of this function to its domain, such that the composition of these two functions, that is g of f is IA and f of g is IB, then this g is called the inverse of f. So we can define the inverse of f as, let f be a function from A to B. If there exists a function such that say g from B to A, such that g of f is IA, means identity function from A to A, and f of g is identity function from B to B, then this g is called the inverse of f, and is denoted by f inverse a. So visually we can say that here f is the given function from a to b, that is here it is set a, here we have set b. Now f is a function from a to b, that is if we consider an element x in a which is mapped or related with y of b, that is here x is related with this y, that is f of x is y. Now if this, for f there exists a function g from b to a, here b is the codomain or domain of this new function and a is codomain. Now this inverse means that this y through this g is related with this back with this y, this x, that is here g is f inverse, actually g is f inverse, that is g of y equals to x. Now g is f inverse, which implies that f inverse of y equals to x, f inverse of y equals to x. So in nutshell we can say that if f is a function from a to b such that x is related with y through this f, now inverse of f means that if there exists another function from b to a such that this element y which is actually related with x through this f, now this should be this should be related back to this with this x. Then if this happens, then this function is which relates y with x, in reverse direction, this function is called the inverse of f, inverse of f. If for any f this function g exists, means f inverse exists, we say that f is invertible function, we say that f is invertible function. So invertible function is that function whose inverse exists, and inverse is that function which relates back, which relates elements in reverse direction, reverse direction. So this was about this inverse function. Now today we will discuss further this concept, that is inverse and invertible functions, through examples. So thank you.